Hiya, it's Mr. Baker here. Today we're going to be looking at velocity and acceleration. Okay, so we're going to be looking at this question. How can I calculate the velocity and acceleration from a speed time graph? So we're going to be looking at speed time graphs, sometimes called velocity time graphs. We're going to be looking at how we can use those to find out some different things. So we have looked in previous lessons at distance time graphs, and so down the left hand side of here we've got some distance time graphs. Distance on the y-axis, time on the x-axis, and we've got three different axes here. Distance always on the y-axis, time always on the x-axis. And then over on the right hand side here we've got speed on the y-axis and we've got time on the x-axis. And what we're going to do is we're going to look at some different distance time graphs and see how those graphs can be drawn as speed time graphs. Okay, so we've already done this. If you haven't looked at distance time graphs, then go back to that lesson on distance time graphs and go through that, because you'll need to do that before we do that. It's quite important. Okay, so if I want to show a slow constant speed, then I would have that line there. If I wanted a fast constant speed, then I'd have that line there. Okay, so this is a slow constant speed down the bottom, this one here, and a fast constant speed is that one there. So slow constant speed, if I drew that on a speed time graph, so on a distance time graph it would look like that, and like an increasing line that goes up like that. But we've said the gradient of a distance time graph shows us the speed. So it's a constant speed, and so a constant speed on a speed time graph, if this axis here is showing a speed, then if it's a constant speed, then the speed isn't changing. So it's just going to be a flat line like that, that isn't zero, but it's not particularly high because it's a slow speed. Fast constant speed is going to be higher up there, because it's a higher line, it's a higher speed. The slope or the gradient of a distance time graph shows us the speed. Okay, so I can take the gradient of this. If that number came out as 10, then that's what that number there would be, 10, all the way along there. If I take the gradient here of the slope of that one, and that came out as 2, then this number down here would be 2. That would be that there. Okay, if something's speeding up, then it would look like that on a distance time graph. So you can see that the line isn't constant. So if I was to take the slope, the gradient of a distance time graph, then it would have a shallow slope there and a steep slope there, so that tells me that it's increasing in speed, it's accelerating. And on a speed time graph, that would look like that. So the speed is increasing over time, so that's accelerating. Something that's slowing down would look like that. The gradient here is bigger than the gradient here, so that tells me if the gradient is the speed, so it's got a high gradient, a high speed here, it's got a low speed here. And so on a speed time graph, it starts off fast and ends up, in this case, 0. So if I was to do the tangent here, then that should be a flat line like that, which would have a gradient of 0, because this has gone all the way down to 0. So the slope of a speed time graph shows us the acceleration. Okay, and that's the other thing. So we've said that the slope of a distance time graph shows us the speed. If I want to find out the acceleration here, I know that this is going at a steady speed. So in other words, the speed isn't changing. So in other words, it's not accelerating or decelerating. The speed is staying the same. On this one, look, I know that it's speeding up. I know that it's accelerating because it's on this one. And I know that it's speeding up because the speed is increasing. If I want to find out how much it's speeding up, how much it's accelerating, I would take the gradient there. And a bigger slope, a bigger gradient would tell me that it's got a bigger acceleration, and a smaller slope would show me that it's got a smaller acceleration. Here, if I take the gradient of this one, this is going to be a negative number, isn't it? Because it's changing, it's going down. And so that tells me that it's decelerating. So a negative acceleration, something's got a minus in front of it, that would tell me that it is slowing down, it's decelerating. Minus and plus in physics tend to tell us the direction that something's travelling, if it's displacement, or in this case it would tell us if something's speeding up or slowing down. So on here, it would tell me if I've got a positive gradient, then it would tell me it's speeding up. If I get a negative gradient, it's slowing down. Okay, so this is a really typical kind of question that you might have to answer. Here we've got a speed time graph here, time on the x-axis, speed on the y-axis, and that's the thing with these questions. A lot of the time you've got to just be really careful about the axes. A lot of students get these questions wrong because they just don't look at what this axis says, and you've just got to be careful that if you're looking at a speed time graph, then you know that it's a speed time graph and not a distance time graph. So we're looking at this question here: what is the acceleration of the object between points A and B? And again, this is really typical. They might say it's 2 different points. It might not be going from the beginning to the end. It might be anywhere on this graph, and they'll ask you to work out something about it. So the acceleration between points A and B. The object's speed is increased by 20 meters per second. So it's gone at B, it's going at 25 meters per second. At A, it's going 5 meters per second. So 25 minus 5, it's increased by 20 meters per second. And it took 4 seconds for that to change. The time at B is 6, and the time at A is 2. So 6 take away 2 is 4. We know that the acceleration is the speed divided by the time, or in other words, the gradient here. So the change in speed divided by the change in time. So the change in speed here is 20. The change in time is 4. 20 divided by 4 equals 5 meters per second squared. And have a look at the units here. So again, so with the acceleration, it's a change in speed over time. Now speed has got the units of meters per second. So speed is in meters per second, time is in seconds. So meters per second divided by seconds. One way I can write that is to write it like this: meters per second squared. You could say meters per second. It's the same kind of idea, meters per second squared there, and that's how we write the unit for acceleration. Okay, if you want to check to see how much you have taken in from this little clip, this little lesson on velocity and acceleration, here's a little quiz, 5 questions here. I pause the video, and then on the next second I will show you the answers for those ones. Okay, so pause it there. Okay, so have you had a go? Let's have a look at the answers then. Okay, so let's see, how'd you do? So the gradient of a distance time graph represents speed, so that's what that is. The velocity of an object is its speed in a given direction. The acceleration of an object is given by the equation. The change in velocity divided by time. So the acceleration is v, which is the final velocity. Take away the u, which is the initial velocity. So that's the change in speed, or the change in velocity. And then time, I suppose we could do the same again. We could do the final time, take away the initial time, but we sometimes just say the change in time there, and then a is the acceleration. So acceleration is the change in velocity, or the change in speed, divided by time. The gradient of velocity time graph represents acceleration. How long in seconds should a train take to stop when accelerating at minus 2 meters per second squared from 30 meters per second? So we use our acceleration equation. So acceleration equals final velocity take away initial velocity all over time. So the acceleration, it says, was minus 2. So minus 2, the final velocity, because it stopped, has got to be 0. The initial velocity was 30. So 0 take away 30 divided by time. And this is how I would do it. If I was doing this in a GCSE exam, I would do it like this. I wouldn't rearrange the equation first and then put the numbers in. I would always put the numbers in first and then rearrange it. And actually, if you look at a lot of the mark schemes, that's what you'll get the marks for. You get the marks for putting in the numbers correctly, so making sure that you've got the right numbers out of the question, out of what it says, and then putting those in, and then rearranging it afterwards. And actually some people find this a lot easier to do it this way around as well. But if I've got minus 30 divided by minus 2 in this example here, then the time is 15 seconds. Okay, how did you do? Hope you did all right on those ones. So this is what you should be able to do then from today's lesson. So you should be able to give the equation relating velocity, acceleration and time and calculate the acceleration of an object using the change in velocity and time. You should be able to compare and contrast the features of a distance time and or a displacement time graph and a velocity time graph. And you should be able to use equations relating to velocity and acceleration. Okay, right, well that's velocity and acceleration lesson over. Thanks very much for watching that. I've been Mr. Baker and I will see you next time.